The title sounds a lot more complicated than it really turned out to be. It's quite fancy to see exactly how the tooling has just evolved to really make something like this just so approachable. Again, like you were saying,
I think the traditional DBA role is changing. I see it as a positive for a DBA because what's happening is a lot of the mundane day-to-day database tasks are being automated, which leaves you then free to look at more interesting things. So you can either go down that route of the data modeling. This is my manifest for creating my Postgres cluster custom resource. So we've still got the master running. So you should, in Hasura, you should still be able to connect to your primary database at the moment. And that shouldn't have caused any issues there.
So I'll hit connect and we'll see if it lets us go all the way through. And we're connected to our Postgres inside of Kubernetes, just like that.
Yep.
Well, hello, everybody, and welcome to the show. We have yet another fantastic set of content for you all today. I'm actually really excited because this is one of the more technically nerdy topics that we've had the pleasure of being able to work on, but one that has such immediate application for so many people building with the Hasura stack. And that is actually about Postgres on Kubernetes. And that's going to be a topic that I think a lot of people find extremely relevant in today's digital age of serverless and cloud computing and containers and the whole nine yards. I will be learning as much, if not more than most of you, because my guest today actually happens to be the expert on this topic from Crunchy Data. We've had more Crunchies join us before. And Karen Jex, it's great to have you today. Thank you for joining us.
Hi, thank you for inviting me. I'm doing really well, thanks. Yeah, I'm excited to be here.
Yeah, so you guys have been having a pretty stellar Postgres spike in the news lately with the introduction of the playground a few weeks back. And this topic is going to be where you're able to take immediately that knowledge that you've gained from learning how to work with Postgres by itself, and now how do you actually deploy this in a way that's going to be everywhere and close to the users and resilient and all that kind of good stuff, right?
Exactly. So many people now are deploying on Kubernetes. They're deploying their applications in Kubernetes. So obviously they're thinking about, okay, how can I bring this to the database as well? And even only a few years ago, people were really hesitant to do that. But the Postgres operators, and particularly the Crunchy Postgres operator, are actually quite mature now, and they can automate so many of your database administration tasks for you that it's the ideal time to give it a go.
Fantastic. Why don't you give the people a little bit of a background on you, sort of kind of how you came into this space of Kubernetes and Postgres, and then we'll have a look at the actual content.
Yeah, so I've had a very database-shaped career. I started out a lot of years ago as an Oracle DBA. I worked as an Oracle DBA for 20 years, and then I discovered Postgres. And I soon started working just with Postgres databases, moved into being a database consultant and now a solutions architect. So I had to kind of gradually move out of my little database-centric bubble and see the other things that are going on around the database. So I still very much work focused on databases, but I see more of the the ecosystem that goes around that.
Yeah, and as an architect too, then you probably had a lot of exposure, not just in sort of where the database or databases or database I'm not actually not sure the plural there. Where that sits, not only just in where companies have that and how they have them deployed, but also just from a business org standpoint, kind of like who are the owners, what are the actual situations where this team maybe owns a specific database and they own a specific database. How do you deal with sort of getting people to let go and give it to the Kubernetes team or whatever, and be able to actually hand this off into a cloud deployed model where it's not like it's underneath, Karen's desk on that computer. We know where the database is. You've probably seen that whole migration process for people from going into this Kubernetes world.
Yeah, so there's we are very much, and I've seen over the last few years a shift away from working with the traditional DBA to now either working with application developers or working with sysadmins. So it seems as though the database is kind of moving in one of two directions in organizations.
That's really fascinating. What do you think is driving that shift? Because clearly, so does that, are those the DBAs themselves diversifying into like more specific topics of knowledge, or is this a trend that is being led by DBAs being owned, or not DBAs, but databases being owned by or introduced by teams, irrespective of what a proper DBA setup would have been inside of a company?
I think it's the latter, that organizations have changed the way that they kind of sit their database teams within the organization. That, you know, with the whole DevOps thing, things are deployed differently, things are looked after differently. So I think the traditional DBA role is changing. I mean, it could be that these are the organizations that I've seen as a consultant, as a solutions architect. Maybe there are a lot of organizations out there that still have that traditional DBA setup, but certainly the ones that we see seem to be moving away from that, you know, the traditional DBA.
Very interesting. So if you're watching this video as a DBA, where would you recommend somebody invest their time learning to sort of be able to move with this shift where there's needing to be an awareness of a lot more DevOps kind of things versus maybe, or go the other direction and go more data models and application developer side? Like, where do you see sort of the trends moving for a DBA who's wanting to upskill, if you will, and expand their portfolio of offerings to stay competitive?
I think it very much depends what the DBA likes doing, because I think that you know, I see it as a positive for a DBA, because what's happening is a lot of the mundane day-to-day database tasks are being automated, which leaves you then free to look at more interesting things. So you can either go down that route of the data modeling, if that's the side of things that you're interested in, or you can go down the route more of the performance tuning, if that's what you're interested in, or look at the bigger picture and do the, you know, more of the solutions architect type thing, or move towards the DevOps where it's actually you doing the automating. So they're actually, I see it as a way for DBAs to actually move towards whatever is they're interested in, but just have some of those day-to-day tasks taken away from them.
And so now, when you say sysops, what are you referring to more specifically, kind of in a bucket? If you were to say like this is what a daily operations for a sysops person does.
That is a very good question. I don't know. I didn't realize I'd used that word.
Was it sysops, or what did you say? So instead of DevOps, it
DevOps,
was
but I could.
okay. I
Could have
thought there
the wrong
was
way.
two terms, and I thought you said DevOps, and so that's why I used it. Then I thought I heard your other term again. I'm like, oh, there's something I don't know. Okay, well, good. So yeah, the DevOps direction. As long I get, like my Twitter bio says, I'm here to ask the stupid questions. So I'm like, oh, there's a whole thing that I don't know about. Oh, very good. So we
I
have
mean,
the
if anyone
DevOps.
does know about it, then please tell us.
Yeah, there you go. Yeah, so in the DevOps side, that's kind of where we're focusing a bit more today, right? We're doing the systems operations. I think that's what you're referring to. Was more of the actual like internal. Okay. So from what we're looking at with Kubernetes, we're looking definitely more on the DevOps side. And do people see a lot of performance increase? Because one of the things about Kubernetes with other parts of the application stack, when you are bringing the containers into deployable groupings of pods, if you will, like you see a speed up in that networking time between these pods because they're sort of deployed oftentimes somewhat closer to each other in its geographical groupings. Is that something people often see as a speed up as well with Postgres, or does that sort of fit in a totally different paradigm?
I think that probably is the case. I don't have that much anecdotal evidence for that at the moment, so we might need to ask some people that have done some research in that. I think one of the main benefits is the fact that you can speed up your deployment so much, and you've got so much more flexibility. So there should be some performance improvements in there because, well, assuming that you're not running your containers on top of VMs, you're taking out the overhead of VMs, which can be kind of 10%.
Assuming your container is not a computer, you're just putting a container inside of a pod and shipping that. Yeah, that's a bit of an anti-pattern, but not one that's uncommon when it comes to hosting databases, for sure. So, well, fantastic. I'm actually super excited because I think this is something we do a lot of Kubernetes. I think Hasura way back in the day started off as a company that was basically deploying Kubernetes for customers, and then they saw a lot of these application development models surfacing and these pieces of the data layer that were not really being handled very well. So that's how Hasura was born organically from this use case. But internally, Kubernetes has a long history with Hasura as a company, anyways. I'm going to bring your screen onto the show here, and we're going to have a look right at the code now and just kind of talk about like where does one start? How do you get going with this idea of Kubernetes with Postgres and Kubernetes, and we'll have a look.
Yep.
So we see your terminal, and
so I'm using VS Code here just for ease of being able to show you what's going on. So it's not necessarily a tool that I would always use. You can use any terminal you want. I'm just using it because I can show you, my everything that's going on in one place. So I'm going to assume that you've already got a Kubernetes cluster available to you and that you know a little bit about Kubernetes, and that you know a little bit about how Postgres works. And what you know is that you want to make the two work together. You want to run Postgres on Kubernetes. If you want to play with this and you don't have a Kubernetes setup already, then you could use one of the cloud providers who usually have free tiers that you can create yourself a cluster to try it out. Or you could try running Minikube or micro Kubernetes locally if you want to. But for now, I've got a
do you have a recommendation on one of those two, micro versus mini?
I don't, I'm afraid. I don't have enough experience of them to know. So I would be interested to know.
Yeah, I'm actually only familiar with Minikube myself, so I'd be curious to hear that too. Hit the YouTube comments, everybody. If you've got an opinion.
Okay, so let me check that I've got connectivity to my Kubernetes cluster. So I'm going to do a kubectl. I'm going to use kubectl all the time to interact with my Kubernetes cluster. So kubectl get nodes. Okay, so I can see I've got 3 nodes available to me. I'm not going to worry at the moment about where I deploy things to. I'm going to let Kubernetes just deal for itself with where it deploys pods to. So the place that I'm going to go to get the examples that we use is the Crunchy Data GitHub repository, and the good folks in the engineering team have created a Postgres operator examples repository. So I'm pulling that from my GitHub because I've already forked that. So you can go to the data GitHub repository, create your own fork, and clone this if you want to have a go with these. So let me have a look here. So they've created sample files for Helm and for Customize. I'm going to use Customize because I can use that with my kubectl commands. And then they've got folders with manifests for various different things. So we've got, for example, the install folder here, which is for installing and deploying the actual operator. So the Postgres operator is what's going to extend Kubernetes so that it can communicate with Postgres, so that it speaks Postgres, if you like. So I am going to go into my folder here. I'm going to go into the Customize folder. So in my install, I've got various different kinds of operator, or PIGO as we call it, installs. I'm just going to choose the default. So to deploy the operator, all I need to do is my kubectl In fact, sorry, before I do that, I'm going to make sure I've created my namespace because I removed that earlier. So I'm going to cheat and cut and paste here. So I'm using kubectl. I'm creating my Postgres operator namespace. And just so that I don't have to do lots of typing later because I'm lazy, I'm going to set that to my default namespace. So let me just check that that's there and that's all configured as I want it. Okay, so I can, my namespace is Postgres operator. Okay, so there I'm all ready now to do my install. So I do my kubectl apply. This is server side to create the custom resource that we need. And then I tell it which folder I'm going to do that in. So it's just in the install default folder. So that's the only command that I need to deploy the Postgres operator. So let's do that. No such file or that's because I've managed to mistype. This is why I should cut and paste. Okay, there we go. So that's applied. So that's now installing the operator and all of the things that it needs to be able to deploy and manage a Postgres cluster. And that's my Postgres operator installed. So let's have a look. We've got kubectl get pods. So that's created as 2 pods. I've got one here, which is my Pigo pod. So that's my operator pod. And I've got one here, which is an upgrade pod, which I don't need at the moment. That's just for when I want to upgrade my operator to a later version. So that's it. That's the Postgres operator itself deployed.
So we have the so you downloaded the project locally, which just has a bunch of commands and config things created. And then that allowed you to go ahead and go in there. You created a namespace first of all, and then you went ahead and you installed, or you ran the script essentially to install the Postgres operator inside of the Kubernetes cluster.
That's right. So I now have so I now have the operator installed, which has now the definition of this Postgres cluster custom resource that we can then use to create our Postgres cluster.
All right. And the you said the upgrade pod is something you would use later on for probably handling a downtime during an upgrade process or something, or?
So that's for upgrading the operator itself, and actually the documentation gives quite clear instructions as to how you do that. But you can automatically, well, we'll see in a little while, but you'll deploy a high availability cluster. So these upgrades will happen on a rolling basis. So actually, the downtime is limited to just a restart of your primary.
Very nice.
Okay, so that's I'll just clear that. That's the operator itself installed. Now I want to create myself a Postgres cluster because that's the whole point of the exercise. So in the Postgres folder, find that here, we've got an example postgres.yaml. I'm just going to copy that. I'm going to create myself a hippo folder. Okay, so now I'm going to open up my postgres.yaml. So this is my manifest for creating my Postgres cluster custom resource. So it's going to create me a cluster called Hippo. This is the image that I'm pulling from the Crunchy Data developer repository. So you can go there and you can browse to see which image is available. This bit here is the Postgres version. So it's pulling Postgres 14.5. Here, this major version has to match whatever you're selecting as your image. And down here, I've got a section for PG backrest because automatically we'll set up PG backrest so that it will take an initial backup of your cluster when that comes up, and then you can configure it. You can put a backup schedule in there, or you can run manual backups if you want to. So what I'm going to do is you can just run this as it is and it will automatically create you that Postgres cluster. But what I'm going to do is I'm just going to make a couple of changes. I'm going to change this to 14.4 purely so I'm deploying a slightly lower version so that I can show you a rolling upgrade later. And I'll just move that to 2.38 for my PG backrest. At the moment, this is going to create me one Postgres cluster, as in one Postgres instance. So I'm going to change the replicas to 2. So that is under my instance name. Here I am going to put replicas 2. So that is replicas in a Kubernetes sense. So that's replicas of the pod. So that's going to be one primary and one standby database. So if I set that to 3, it would be 3 pods, but one primary, 2 standbys.
1 primary, 2 replicas.
So this case with
it's inclusive for all of them.
Exactly.
I think I just went very German on that. It's inclusive. Sorry, of the pods. Yeah. Okay.
Mm-hmm. Yeah. Okay. So we're going to have 1 primary, 1 standby. So that's all I'm going to change for now. The bit that I usually forget is save the changes to the file. And then I'm going to apply that. So kubectl apply again on my Hippo folder.
I have questions. Why Hippo? Is this a convention, or is this just what you use, or is this a crunchy thing, or?
Hippo is the crunchy data logo.
Oh, it's okay. That's what it is. I was wondering. I didn't look it up, but I was like, yep. I wonder if it's the crunchy data thing. Okay.
Okay, so for a change, I didn't make any indentation errors there, so that seems to have created okay. So now I'm going to do just a watch. I get pods to see what's happening. So everything, whilst we were speaking for that brief time there, everything is running. So I've got my repo is my PG backrest repository. I've got my 2 instances. So one of those is my primary, one's my standby. We'll see in a bit how you can see which is which of those. I've also got my initial backup that's running. And there I can see already that's completed. So that's it. I've set up, I've installed and deployed the operator, and I've deployed a Postgres high availability cluster, and I've taken a backup of my database.
And like looking at those, I mean, those are all very configurable commands. So this is something that you can very easily port to like a GitHub action or some kind of a deployment workflow to be able to make this be a deployable script, right?
Exactly.
All right, great.
Exactly.
I mean, so we got Postgres running.
These are samples. You know, it's called. Yep. Cool.
We have some delays for our audience. I'm living in a very low network connectivity, like small village in Germany, and Karen's calling from the mountains. So we're doing the best we can with the infrastructure today. So we're doing what we can.
Well, we have Postgres installed and our high availability cluster deployed. So all good.
Yeah.
Okay. So I'd said that I was going to show how we can find out which is the primary and which is the standby database. So let's do that. And this I'm not going to try and type live because I'll definitely get that wrong. But we're looking at the labels. So we're looking at this role label and we want to find just instances. So I'm just looking at pods that are an instance type. And there I can see that I've got my master and replica. So a primary and a standby. So if I need to know, I can check which pod's which.
Very good. And then when you run upgrades, then do you just run that on the primary, or do you have to run that across all the pods, or will the replicas follow the upgrade behavior?
So they'll follow. So the operator will handle a rolling upgrade.
Okay, so it'll upgrade initially and say okay, and then the rest of the ones can start to roll out. And then obviously you wouldn't be installing any extensions or anything until all of your upgrades are running the latest, right?
So we've got the database, kind of handy to be able to connect to the database. the endpoints that we have. So we can see that we've got a Hippo primary and a Hippo replicas endpoint. So the Hippo primary actually then points to the Hippo HA, but we don't need to worry too much about that. Just to know that Hippo primary will always point to the current primary database. So Petroni looks after the high availability cluster. It will make sure that Hippo HA is always pointing to whichever is our current primary database.
Okay.
Hippo replicas uses selectors, so it will look to find out which pods have a read-only database on them, so that it knows which are our replica or standby database.
Okay, so now how do we get this data out of the cluster into a way that we'd be able to like put it inside of Hasura?
So we can, at the moment, we've got services that are only exposed within our Kubernetes cluster. So what we can do is we can expose one of those services. We can expose our Hippo HA service so that it's available from outside the cluster. And then what I was thinking is if I give you the database connection details, then maybe you can create that as a data source in Hasura.
Sounds good. Let's try that.
Okay, so what I need to do is make a change to my service type. So back in my manifest, it's one of the options under spec. So I'm going to do service.
And when you say the HA service, so this is the HA service is the operator, or what's the HA service?
It's the operator that defines that. Yeah.
So and would I, because in his sorry, I'm asking some new questions here.
Yeah.
So inside of Hasura, I can define my primary and my standby endpoints. With the HA service, do I need to do that, or does it automatically now I give it one endpoint and it's able to actually sort of route traffic for me to these different database if it needs to, or do I still expose my primary and my standby URLs that are connection strings that I would then add into whatever tool that I'm working with?
Yeah, so the Hippo HA is the one that will always point to the primary. So if you configure that, it will always point to the primary. And then you'd need to do some work to expose the replica service to be able to put that in. So it would always point to the correct place once you've configured that in Hasura.
What's the rough flow? We don't have to do it if it's a bit more on the config side. What would be the process to actually expose the replica if we wanted to do that?
It should just be a case of patching the service.
Okay, and you just add an exposed port or something.
Yeah, so it's got the port. So with this one here, this is for the HA service that I'm going to do now. So I just put in type load balancer in there. So this will expose the HA service. So I've saved that in theory. Let me do an apply again. So the default service type is cluster IP, which is so that it's only available internally to the Kubernetes cluster. But I've just changed that to load balancer. So if I have a look now at my services, so we're waiting for an external IP.
And if you're, for the audience watching this, so obviously you're all going to be using Hasura Cloud because it's the best way to run Hasuras, obviously. But if you were to be running Hasura inside of Kubernetes cluster, because it is open source, you can do it that way, then you wouldn't actually even need to be exposing it. You could be able to just do a network internally and be able to have a deployable, just highly available cluster, which is quite fantastic, actually.
Yep. Yeah. So we've got our IP, we've got the port, it's on 5432 because that's the default, but another thing that's configurable if you wanted to use a different port. I didn't specify a user database to create, but if I don't specify that, then the operator assumes that I want one, so it creates me a database and a user as my cluster. So I automatically have created a Hippo database and a Hippo user that can access that database. And it will also have created me a secret that contains all of the connection details for that user. So I'm going to have a look in that secret and I'm going to get out the password. So let me do that. Okay, so here is my password for the Hippo user. So in theory, we now have everything that
You
we
can
need.
drop that in chat here because I'm not
Exactly.
gonna try to read
You're
that
not going
and
to try and
type
type
it.
that in? No. The username's Hippo. The database is Hippo. What else did we need? Did you capture the IP address, or do you need me to share that?
Good. And I think that's probably everything we need. Well, that looks so. I've got everything plugged in here for Hasura. And if we, in theory, all we got to do is just hit go. So give us a name here for local metadata. So we'll call it default, or we'll call it the Hippo actually for our local database. Postgres driver, we're using connection parameters. We've passed in the host, the port, the user, the secret, and the database name. So here's where we could add our read replica, but we're not going to do that this time. So I'll hit connect and we'll see if it lets us go all the way through. And we're connected to our Postgres inside of Kubernetes, just like that.
Yep.
Quite cool, actually.
Yeah, start to finish in that time, and obviously it's taken longer because we've been chatting about it as we've done it. But
yeah. Right, yeah, no, that's quite incredible. So we have everything connected. It's all in place. What would you then do to be able to run upgrades on this instance? I'm going to go ahead and put your screen back on there. And
okay. All right, let me show you the process of upgrading. What have I done now? Okay, so if I want to upgrade my Postgres, so here we had 14.4. If I want to upgrade that to 14.5, for example, and I'm going to upgrade PG Backrest to 2.40. I think those are the latest versions there. Okay, so I'm going to save that. And before I apply it, we'll just get the current version. So I'm going to cut and paste just because it's quite a long command and I'm bound to make mistakes otherwise. So I'm doing an exec into my primary database pod. So it's selecting here role equals master. And then it's doing a PSQL and it's passing in the command select version. So I'm executing into my primary database pod and executing a command in PSQL. So there we go. I've got my version. So that's telling me that I'm currently running Postgres 14.4. So what I'm going to do, I'm not sure how well you'll be able to see this. So let me know. I'm going to split that and I'm going to do a watch on the get pod command that we had before so that we can watch it do the rolling upgrade. So let me try and get that a bit visible. Okay, so this one on the right is what we want to watch anyway. Actually, what I'm going to do before I do that, I'm going to add in an extra replica because it's easier to see when we've got three instances. So let me just put those back. Oops, apologies there. Okay, put that back to 14.4, put that back to 2.38. And I'm just going to add, so this again, you'll see how easy it is to scale up. You'll be able to see that as it happens as well. So I've changed replicas to 3. I'm going to save that and do my apply. And we should see an extra, there we go, it's just standing me up another pod there. And that should bring that into the cluster as a replica. And whilst we wait for that to happen, I'll go back now and change these again. So 14.5 and 2.40. So that's already brought me in that extra instance as a replica. Okay, so I've changed my versions. I'll save that again. I'm going to redo my apply. kubectl apply minus k hippo. It's not very easy to see. I apologize there. Let me just clear that a bit. Okay, so I've applied those changes. And now what we should see over on the right is that it will do that rolling upgrade. So we've still got the master running. So you should, in Hasura, you should still be able to connect to your primary database at the moment. And that shouldn't have caused any issues there. But what it's doing is it's going to do the upgrade of the 2 replicas first. Then it'll do a switch over so that one of the replicas becomes the current primary. And then it will upgrade the old primary. So the only downtime that you should get is just whilst it does that switch over.
And how long does that switch over typically happen? Is that fairly instantaneous?
Yeah. I mean, you should see that happen. So where are we at the moment? We've still got the same master, so that's doing the second, and you can see approximately how long that's taking. I think it's about a minute for each one that it does the upgrade on.
But like this also, I mean, typically for a DBA, this is the part where you just start getting a little warm behind the collar as you're waiting to kind of hope that like the upgrade happens so you can bring the database back online, because you were staying after work and it's already, I don't know, maybe around midnight or something, because you don't do it during your customers' uptime. And you were trying to explain to your boss how there is no such thing as a internet, business hours. But so this is now something that you hit get deploy, and you're actually just checking back in every now and then on the status log to see what the actual, the status is for when it's switched over. But like, you don't have to worry because your old one's running. The next pod is upgraded and it's getting ready to be switched over. Like, that takes out so much of the headache and so much of the high risks poker for for Postgres or any database administration. Is really like this. I'm wondering, why was there so much pushback in the past about deploying Postgres in a cluster like this?
Well, because originally containers really weren't designed for databases. They were designed for stateless applications, and a database isn't stateless. A database has data. If you lose a pod, you don't want to lose the data associated with it. So yeah. So now that we've got persistent volumes and we've got stateful sets, we actually have the ability to store our data and to recognize that, for example, a primary and a standby database pod aren't just interchangeable.
So this really comes down to it being a question about the persisted data. So the pods were not designed to be able to have any kind of persistence or predictability of persistence, and now they can. And would a best practice say, when you have a backup created, do another trigger to just sort of pull that data out of a pod and store that somewhere else and another sort of persistence? Or what does convention say these days when you do have snapshots and backups from containerized databases?
So we automatically set up PG backrest, and that can be used to send your backups and your archived walls to pretty much any storage. So you could send that off to S3. You can send it to wherever you want. So you make sure that you've stored your backup data somewhere persistent, somewhere that you can get that back from.
Okay.
Yep.
So do we have our switch over yet?
That was done ages ago whilst we were chatting.
Oh, okay.
Sorry. Yeah, look, we've got this one here now is our master. So we should now check.
And if we exec into that again, we should see that we got 15.5, right? Or 14.5, right?
Select version 14.5. There you go.
That almost just feels too easy.
Yeah, it's like magic. I think
really
that's
really
one
cool.
of the things I love about it. It's obviously a lot of work has gone into that behind the scenes to make it look like magic. So
I mean, yeah. So So, what does it take for a team to be able to switch from an existing running instance of Postgres these days to sort of embrace a containerized approach? Is it just kind of set one up in parallel, do a data migration to the new Postgres instance, and then at some point switch over your environment variables to the new endpoint?
Yeah, so it's the same with any database migration. You just need to really think about how you're going to do that. But taking a step back, I'd say that it's really important to kind of map out how you want to do that anyway. So make sure that you've got a team in place that knows how to work with a containerized environment. Don't just assume that everything's going to be the same as it always was. You need to be fully embracing that. So I think that's one thing. And then make sure it's the same as any other database migration. It's going to depend on the size of your database, how active your database is, how much downtime you can afford, that comes to which technique you use to migrate over.
Yeah, that I think is actually so. I mean, nobody just deploys Kubernetes for their stack. So I think that's an interesting case where it sort of brings us back a little bit full circle into this thinking about, well, what is the changing role and position of a DBA? And when you do sort of have this bifurcation, some of them are going to go more towards the data modeling application engineer side to really be able to help get the data model correct. And then the other side, when you do have a DBA tooled up or even sitting with the DevOps team, is able to say, okay, here's sort of how you plan around upgrades and downtimes, and here's what you need to be kind of thinking about, and the Postgres side of it. That does then allow for this sort of deployment model to be really, really effective.
Yep.
And so that's that really, it's kind of an interesting piece to see sort of how that does naturally sort of work out that way, and then also why it does make sense to say, okay, if you have a DevOps team for Kubernetes, you should get somebody who knows databases in there, like really well. Like get the
Yep.
need for a DBA, the strategy of how do you do deployments and what kind of data and how do you set up backups and what's a good idea of persistence, still is really critical. It's
Yep.
just they're now sitting
Absolutely.
in a different team than they were before.
Exactly. I
And
mean, there've been so many times over the past 20 years of my career, I'll say, that we've been told that the DBA is going to be extinct, and that's definitely not the case. It's not happened yet, and I don't think it's going to happen. It's just that the role evolves, the role changes, and hopefully for the better, because the more boring side of things are being automated, the more error prone side are being automated, and you get to actually look at bigger picture and do more interesting projects.
yeah, I mean, we see that all the time with Hasura, and I think there's actually a bit of a parallel story here, because in the Hasura side, what we often see happen is we'll get teams that, okay, they get a database set up and they get their data in there, and then they're like, okay, now we're going to go ahead and embrace GraphQL and this Hasura tool that we just discovered, and we're going to set across these 5 sprints to get our resolvers and everything set up for this API. They put it into Hasura, and then they like, oh, it's done. Like the API is done. We don't have to do anything else. Like it was like we had a month for this, and we've got it done this week. Let's go back to the database and actually rework it. If it was that fast to expose this, let's go ahead and actually rethink through our data model. And time again, we see people always come back to say, okay, if we can actually just so cleanly get access to our data model this way, let's go back and focus on the data model. And that's where the DBA really comes into shine, because it's able to say, hey, this is a situation where if you can get a really well-defined, well-designed, and well-optimized database, it's going to elevate your Hasura experience so much more, because all it's doing is it's just passing through it, ultimately, that kind of experience from the database to then a GraphQL API. And then from the DevOps side, it's sort of similar. It's like, well, the deployment actually is no longer a headache. It's pretty straightforward to deploy this database now in our environment. So what else can this database do? What else, like what other plugins or what other kinds of things can we optimize with the database, and just focus on the actual database itself and not worry about, well, we need to have all this time for deployment and integrations and everything else. And so I think that this is an area where the DBA does have a very vital role to say, hey,
Yep.
let's bring that DBA specialization into these teams, so there's no longer this fighting of the old way and the new way, but just bringing that skill set into those teams and being able to say, okay, for the application side, the data modeling, we're going to go ahead and go really well on that. The deployment side, yes, we can support these extensions or whatever else that you've been asking for, and get some pretty cool stuff set up and build cool things ultimately. But
yep, and there's still all of the making sure that you've got the right parameters set up for Postgres. You know, the sample scripts will, and the operator give you the ability to make changes to set the parameters the way you want. But obviously, ultimately, you as a DBA will know what's right for your environment, and you know that's for you to test. And one thing I hadn't said is that you've got these manifests are declarative, so you're just giving Kubernetes the information about what you want your cluster to look like. You're not giving it the step-by-step, this is how I want you to get there. So, you know, if you want to change those parameters, that's fine. Just make those changes in your manifest and it will apply those changes to, you know, to make your cluster look the way you want it. So,
which obviously makes lift and shift cycle like a super easy thing too. So you're building in the ability to say, hey, we're moving to this other cloud provider. Okay, here's my YAML file.
Yeah. And that's kind of one of the things that Kubernetes is good at. You know, it's portable. You move things to wherever you want them to be.
Very cool. Well, that was actually it for the show. The title sounds a lot more complicated than it really turned out to be. It's quite fancy to see exactly how the tooling has just evolved to really make something like this just so approachable. Again, like you were saying, there's a lot of stuff going on inside of those folders, but
thanks to the engineering team at Crunchy, definitely, that it looks so easy.
Yeah. Do you have three things that you would point a DBA to these days for next steps in their learning, or things to check out if somebody wants to even a non-DBA wants to actually step up their experience or skill set and organically bring these sort of talents into their team?
Well, definitely looking at Kubernetes, and like I say, it's easy to set up a cluster now because you've got the free tiers from the cloud providers, or you've got these versions that you can just set up on your laptop and have a play. The Kubernetes documentation is actually quite accessible. So there are loads of tutorials and things around, but the documentation itself is quite accessible. So, you know, just kind of have a play with that, really. It definitely seems to be the way a lot of organizations are going. So I think learning about containers and Kubernetes can only be a good thing. For non-DBAs, I have to say, check out the Playground because it is really cool.
Postgres Playground, if you want to Google, just because that's the SEO juice. I think you'll find it faster than the Crunchy Playground. Playground, you might get hits that you're not expecting. I'm not sure, but
yeah.
Well, Karen, I really appreciate having you on the show today. It was a lot of fun to see that. I'm going to go play with that because that looks really cool.
Right.
Have a great rest of your day, and that'll wrap it for this show today. Is there any place they can find you? We'll put your Twitter in the profile so that everybody can follow you on social.
Yeah, Twitter and LinkedIn. I have an uncommon surname, so I'm quite to find.
Very good. All right, everybody. We'll see you next week for the next show. Have a great rest of your day.